Hello, this is lesson 1 of module 2. Today we will be looking at how opposite quantities combine to make 0. And to begin this, first we're just going to start with just a general discussion of positive and negative numbers in a Venn diagram. So what I would like for you to do here on exercise 1 is to use the graphic organizer in the picture to record what you know about positive and negative numbers. If you would pause the video and complete this Venn diagram on your own, we'll go over some possible solutions in just a moment. Okay, so here you see some possible answers that you could have in your Venn diagram. Any of these terms would indicate negative numbers. Negative numbers are left of 0, they're below 0. Some of the terms you might have used in 6th grade to indicate negative numbers would be a loss, a debit, below sea level, withdraw, owe. These are all words that you would know indicate negative numbers. For positive numbers, you might use terms like right of 0, above 0, gain, credit, above sea level, deposit, or earn. This is not an exhaustive list of words. You could have many different answers that would be good answers, just so that you have some of these written down and can determine what vocabulary determines negative numbers and positive numbers. Some things that are true about both positive and negative numbers. They can be integers. Integers is the unit that we are working on right now. It refers to all numbers, positive and negative, that are whole numbers, positive or negative. Positive and negative numbers could also have the same absolute value, and that's actually what we're going to be looking at today, is positive and negative numbers that have the same absolute value. That's going to be a big part of our lesson. All right, now for part 2.
Okay, looking at example 2, counting up and counting down on the number line. We're going to use this number line to take a look at the counting up and the counting down. So starting at 0, if I were to count up, it would be a positive number. So I'm going to write that down here, positive. And if from 0 I were to count down, that would be a negative number. So notice that right movement was a positive and that left movement was a negative. Okay, let's take a look at this number line right here. And we're going to take a look at counting up from 0. So from 0, I'm going to count my jumps. 1, 2, 3, 4, 5, 6, 7. And I'm going to put a little arrow right there just so I know that I was going in that direction. That would be positive 7. Now notice I counted 7 jumps. That was my distance from 0. Now let's look at negative 7. We're going to also graph that using the jump method. 1, 2, 3, 4, 5, 6, 7. Now notice again that was 7 jumps. Okay, I'm pointing that out because that is absolute value when they have the same distance from 0, which 7 and negative 7 do. So I've identified that as negative 7. So absolute value is the same. They're having the same distance from 0. Where do you begin when you're locating a number on the number line? Think about where I started. We always want to start at 0. Okay? So let's go take a look at this right here. What do you call the distance between a number and 0? You've heard me say it. If you need a little hint, it started with an A. Absolute value. Absolute value is the jumps or the distance from 0 to a number. So what is the relationship between 7 and negative 7? Well, because one is positive and one is negative, and they have the same absolute value, they are opposites. So 7 and negative 7 are opposites because they have the same absolute value.
Example 3. What is the sum of the card values shown? Use the counting on method to provide the number. Restart. Okay, I'm good. Good. I'll just put that out. Example 3. Using the integer game and the number line. What is the sum of the card values shown? Use the counting on method on the provided number line to justify your answer. So we are going to actually plot the movement for our cards if we were playing the integer card game. So for 5, of course we would start at 0. Start at 0. This is a positive number, so we're going to go to the right 5 spots, starting at 0. 1, 2, 3, 4, 5. And this is where I landed. The next card is negative 5, which tells me I'm going to go left 5 spots. So, from my current location, I start the next move. So from here, where I am, 1, 2, 3, 4, 5, and I went left. The next card is negative 4. Again, from my current location, I start the next move. I'm currently here at 0, 1, 2, 3, 4 spots left. And I went left because it was a negative. The negative indicates the direction. The number indicates the magnitude, or the length. The final card I have in my hand is an 8. That's a positive number, so I'm going to go right 8 spaces from my current location. I'm currently here. 1, 2, 3, 4, 5, 6, 7, 8. This is my landing spot. What is the final position? 4. If this is my current location, what possible combination of cards would I need to get back to 0? So we're talking about going back here to the 0. So I could have one card, which would be left negative 4. So I could have negative 4, and that would work. What if I had 2 cards? Cover the same distance. I could go left 1, and then left 3. So I could have a negative 1 and a negative 3. Or, same distance, I could have a negative 2 and a negative 2. If I wanted to be really fancy, here's my thinking cap, I could have, let's see, I'm at 4. What if I went forward 2 spaces and then backward 6 spaces? So I could have a positive 2 and a negative 6. The possibilities are actually endless.
All right, exercise 2, we're going to begin to hone on the actual idea of additive inverse and to work on that definition. So our goal here is to use the number line to answer each of the following questions. Question A says, how far is 7 from 0 and in which direction? So if you'll notice, the question asks both for a distance and a direction. So we're going to introduce some vocabulary here. That vocabulary is the word vector. Vectors are used to model integers. Whenever we model integers with vectors, we are going to model distance and direction. Now, if we think about distance, what would determine the distance or the length of my vector? That's going to be the absolute value of a number. Absolute value. When we think about what will determine the direction is going to be determined by the sign. If it is negative, we'll go to the left, and if it's positive, we'll go to the right. Right, so let's look at A again. How far is 7 from 0, and in which direction? Well, if I begin at 0, and we're not going to use the counting on method, we're not going to use the bunny hops, we're going to actually draw a vector. If I start at 0 and I move 7 spaces to the right, I would be at 7. So my vector is 7 to the right of 0. Now, we've already introduced the idea of opposites, and opposite is has the same absolute value. So what number would have the same absolute value as 7? And that number would be negative 7. How far is negative 7 from 0, and in which direction? Well, negative 7 would be 7 spaces from 0. Let's go back to our number line, consult the number line. Negative 7 is 7 spaces from 0, and it is to the left. So I'm actually going to, just for the sake of our model, I'm going to start at the end of our previous vector, and I'm going to use a vector that is negative 7. Okay, so that vector was 7 spaces to the left. Now, thinking back to our previous work, could we explain how we would use the counting on method to represent the following? While playing the integer game, the first card selected is 7, and the second card selected is negative 7. So if I had a value of 7, 1, 2, 3, 4, 5, 6, 7, and then I have a value of negative 7, 1, 2, 3, 4, 5, 6, 7, you can see that 7 to the right and 7 to the left would leave me back at 0. So in question E, what does it tell us about their sum? We could say that the sum is 0. And if we look at the arrows that we drew for 7 and negative 7, come back to the arrows, what relationship exists between the two arrows that would support your claim? And what you notice is that each of these arrows, while they go a different direction, they both have the same distance. So I would say both arrows have the same distance or length. And remember that length is determined by absolute value. So we could say that both of these vectors have the same absolute value. Both of these integers have the same absolute value. But they go in different directions. So our question here is to make a conclusion. Do we think that this will hold true for the sum of any number and its opposite? And the answer to that is yes. We do feel like this will be true for any number and its opposite. And we can say, just as a rule, that any number and its opposite will have a sum of 0. Any number and its opposite have a sum of 0. And let's defend that. Because they have the same distance or absolute value, but opposite signs or direction. We can go back in and put absolute value here over distance as well.